So, ladies and gentlemen, boys and girls, we have a very eminent scientist of Central Roads Research Institute, New Delhi, under the aegis of Council of Scientific and Industrial Research, and we would like to hear from him a very brief speech, brief note. So please welcome him with a big hand on the stage. Sri Satish Pandey from CRRI, Principal Scientist, New Delhi.
So, very good afternoon to all the esteemed engineers in the hall, the respected Chief Guest, Mr. Arun Kumar Singh, Development Commissioner and Additional Chief Secretary, Government of Jharkhand. The guest of honor of today's function, Sri Ajay Kumar Singh, Principal Secretary, Rural World Department, Government of Jharkhand. Sri Sushil Kumar, Secretary, Road Construction Development Department, Government of Jharkhand. And Mr. MANISH RANJAN, Secretary, Drinking Water and Sanitation Department, Government of Jharkhand. It's indeed my pleasure to be the part of 56th Engineers Day function in the state of Jharkhand, organized by Jharkhand Engineering State Association. So, like this day is celebrated to commemorate the birth anniversary of Mokshgundam Visvesvaraya, who contributed some pioneering infrastructure development in India in terms of Krishna Sagar Dam, irrigation system in Deccan Plateau, and the flood protection system in the state of Jharkhand. So being a civil engineer, I can always cherish his profound contribution for the development of nation. And the Mokshgundam Visvesvaraya is way back, like in 1940-50, always considered the concept of sustainable development by stating that the engineers can really do the service of nation by contributing something which cannot be measured and bought through money. So sustainable development is one such concept through which cannot be monitored and measured in terms of monetary aspect. Roads is always considered as a lifeline of the nation, and it is one of the precursor for infrastructure and economic development of any state. I started my circular economy as well as the sustainable development journey with the state of Jharkhand by constructing steel slag road at Jamshedpur in 2013-14, as well as the demonstration trial and the field trial of cold mix technology carried out way back in the state of Jharkhand under my supervision in 2011 to 2013. So road can be considered as one of the major contributor of carbon dioxide emission in the environment. In order to construct a 1 kilometer 6-lane road, we usually generate 80 to 90,000 per ton carbon dioxide in the environment, which is substantial in nature and contributes significantly in the global warming. In this direction, the CSIR Central Road Research Institute, since its inception in 1951, keep on developing in eco-friendly green technologies for construction, maintenance and rehabilitation of roads. We have the technology called the terra surfacing, through which the existing road material can be reutilized along with the industrial waste of steel slag for preventive and periodic renewal of the road. Besides that, the bituminous layer can be recycled using RejuPave technology, through which we can utilize 60 to 80% reclaimed asphalt pavement material in road construction. So by adopting this sustainable mechanism as well as the reutilizing the industrial waste material in the road construction, we can ensure the green infrastructure construction in the state of Jharkhand. The CSIR Central Road Research Institute has the technological collaboration with Road Construction Department of Government Jharkhand, and we have signed a memorandum of understanding in this regard way back in 2016. And we will be more than happy to help you out to adopt all eco-friendly construction technologies in the state for the overall benefit and the maintenance of the road construction activity. That's all from my side. Thank you very much. And once again,
girls and boys, we have with us the first speaker. He is an eminent scientist, Principal Scientist of Central Road Research Institute, New Delhi. And he had spoken a few words in the inaugural session also. So, a few words about him. Mr. Satish Pandey is associated as an Associate Professor in Academy of Science and Industrial Research an institute of national importance, border organization, Government of India. As an officer on board, he has around 15 years of long research experience in the field of transportation, highway engineering, as a scientist in CRRI. Mr. Pandey is credited with publishing around 28 research papers in national and international journals, conference, and hold 2 patents. He is the inventor of cost-effective maintenance and rehabilitation technologies, reju-pave terra surfacing, modified mixed surfacing, cold mix technology, macro surfacing, and steel slag road. Mr. Pandey also did several R&D projects for leading steel industries in India, such as Tata Steel, JSW Steel, ArcelorMittal Nippon Steel, Harsesco, SAIL, Rashtriya Ispat Nigam Limited, to facilitate utilization of iron and steel slag as road construction aggregates. He is the recipient of Global Slag Personality of the Year Award 2023 by Global Slag Germany, CSIR Technology Award 2017 from Honorable President of India at Vigyan Bhavan under Environmental and Sustainability Catering for facilitating successful valorization and utilization of steel slag in road construction. He is credited to establish state-of-art Center for Research on Steel Slag, first of its kind in India, to facilitate research on steel slag and allied products for possible utilization in infrastructure projects. जितने भी लोग बाहर में हैं कृपया आ जाएं, क्योंकि तकनीकी सत्र प्रारंभ हो चुका है. सबको निवेदन है. Now I invite Mr. Satish Pandey on the stage. Please give him a big hand, thunderous applause.
Thank you, sir, for your kind words. And once again, very good afternoon to all of you. So today's my presentation is basically on 2 environmental friendly technology which has been developed by CSIR Central Road Research Institute along with Verma Industries for payment, recycling and preventive maintenance. One is terra surfacing technology and another one is reju-pave technology. So I will begin my presentation with reju-pave technology. So in India, like 95% road network are built through bituminous pavement. Bituminous roads, blacktop surfacing is everywhere. And what we know that like in every 4-5 years we require an overlay on top of it in order to improve the riding quality. So this sort of overlay in every year required good amount of natural aggregate as well as bitumen in order to prepare the bituminous mix, particularly the dense bituminous macadam and bituminous concrete, which has substantial cost of production as well as require huge amount of natural aggregates. So as per an estimate, around 1.2 billion ton natural aggregates are required every year in India for construction and rehabilitation of bituminous pavement. So now this is the time like where we should rely on the options of pavement recycling, bituminous pavement recycling, in order to reduce our reliance on natural aggregate and bitumen. So every year in India, around 60% bitumen are imported. So if we can reuse the existing aggregate and bitumen for the production of fresh bituminous mixes, then it will really be a great service to the nation, being a civil engineer. So in this direction, the CSIR Central Road Research Institute worked with Verma Industries, and under a sponsored research project, we have developed the India's first bituminous rejuvenator called reju-pave, which facilitates 60 to 70% reclaimed asphalt pavement material utilization in bituminous mixes. So the presently, as per the current practices prevalent under IRC and MORTH specification, we can hardly reutilize 20 to 25% RAP in the recycled bituminous mixes. But with the help of this reju-pave technology, we can reuse 60 to 70% RAP in the bituminous mix. And the reclaimed asphalt pavement material, for your information, like I just want to brief about it. The RAP is primarily the composition of natural aggregate and oxidized binder. So when you will mill the distressed bituminous surfaces, then RAP will be extracted, which will comprise the natural aggregate and oxidized bitumen binder, and this binder in the RAP may be in the tune of 3 to 4.5%. So with the help of this reju-pave rejuvenator, we can replenish the oxidized properties of bituminous binder and we can reutilize it into the fresh bituminous mixes. So parallelly, we are reusing the natural aggregate which you have retrieved from the distressed surface. Besides that, the bituminous binder, which is almost dormant in condition, we can reactivate it and reutilize into the bituminous mixes. So what is the this rejuvenator is a kind of a bio-oil based liquid rejuvenator which we can utilize directly into the bitumen tank along with the virgin bitumen binder, or can spread directly on the pug mill on top of a wrap, reclaimed asphalt pavement material. So with the help of it, you can redo or recycle the bituminous mixes of dense bituminous macadam, bituminous concrete, semi-dense bituminous concrete, like that. Besides that, you can also use in the stone matrix asphalt. So in one of the NH53s, the National Highway section in Surat, I am utilizing 50% reclaimed asphalt pavement material along with processed steel slag aggregate. So parallelly, whatever the distressed material has been recovered, we are reutilizing it with processed steel slag aggregate. So there is no natural virgin aggregate inside it. The balance quantity of the bitumen, like 1 to 2%, can be added with the help of a virgin VG40 or VG30 grade binder. So in this regard, we have received the patent, it is India's first bio-oil based rejuvenator. Most of the rejuvenator in India are imported, but this is first in India, which has been developed through natural resources, renewable resources, and it's a bio-oil based, therefore it is environmental friendly too. Since majority of rejuvenator are derived through the petrochemical material, but this is completely a bio-oil based, therefore it facilitates high RAP utilization without altering the rheological properties of bituminous binder. So we conducted the extensive rheological test during its developmental stage, which comprises dynamic shear, rheometer analysis, pressure gauge vessel, and all that. So it's a complete scientific study. We have published a couple of papers out of it, so which you can just find out on Google regarding the technological aspects. So without going into technological thing, I will just, this is the dynamic shear rheometer test using RejuPave. I would like to highlight the process which involve into recycling aspect. So the majority of bituminous roads are like that, you will have the surface cracks, map cracking on the surface, which is primarily due to the oxidization of bitumen. But in top of it, if you will do the bituminous overlay, iske upar agar aap koi nayi bituminous layer dal dete hain, jaise aapne DBM या BC 30, 40 mm, 50 mm DBM, 40 BC कर दी, तो कुछ टाइम के बाद ये जो cracks हैं, these cracks can be reflected into the new layer also. So therefore, the service life of your new layer will remain only limited to 3 to 4 years. So in place of it, when you will put a new layer on top of it, what you will do, you have to use natural aggregate along with the virgin bitumen and then prepare the fresh mix. So in place of it, what we can do, we can mill the material from the distressed bituminous surface, we can bring it to the hot end plant project site, and where we can classify the RAP into coarse and fine RAP, and then we can develop a job mix using RejuPave rejuvenator, and 60 to 70% RAP material can be reutilized into fresh bituminous mix. So it will bring down the cost of production by 30 to 40%. So this is the substantial saving. Besides saving the natural aggregate and bitumen, you are reducing the per ton cost of production of your bituminous mixes. Now, what are the added advantages? This is in terms of the circular economy, conservation of nature and all. What are the added advantage in terms of durability? This RejuPave rejuvenator retards the oxidation process of the bituminous mixes. So if you will putting this rejuvenator in the recycled mix, it will prolong the oxidation process. So whatever the new surface you are laying, in case of that, this surface is going to last at least 6 to 7 years. So oxidative hardening will be very slow in this type of surface. Parallelly, the RejuPave rejuvenator also act as a warm mix additive. So in case the conventional bituminous mixes is required to produce between 150 to 160 degrees centigrade temperature, and we have to lay it between 120 to 130 degrees centigrade temperature in order to achieve the requisite field density. But with the help of it, you can reduce the production temperature by 10 to 15 degrees centigrade. You can produce the mix at 130 to 140 degrees centigrade, and you can easily compact between 100 to 115 degrees centigrade. centigrade. So it acts as a warm mix additive, so it will help us to conserve the energy during the production process. Besides that, it provides a long window to you in order to compact the mix into the site. So in case of low temperature areas or where there is the rainy season and all, this kind of technology can really help you to construct a good quality road. So this is altogether the process flow chart. So this is the milling, then reutilization in the site and all. This is not changing. So what we did, like we demonstrated this particular technology on couple of projects in India. Yes. So this is the glimpse of one of the distressed bituminous road of Delhi PWD. This is one of the ring road section, one of the busiest road. So here you can see there is the extensive map tracking. So we carried out extensive analysis by extracting bituminous cores of it and find out what is the quantum of distress and the depth of distress, whether it is limited to the surface cores or it has gone up to the dense bituminous macadam layer. Based upon that, we developed this entire study and extracted the bituminous material from the road surface and carried out. This is the glimpse of a RAP, reclaimed asphalt pavement material extracted from the distressed bituminous pavement. So it contains around 3.5% bituminous binder, and it is good and good quantity of natural aggregate. It is all natural aggregate. So what we did, like we reutilized this, we classified into coarse and fine RAP by segregating it into minus 10 mm and plus 10 mm, and with the help of it, we devised the mechanism to put it into the hot mix plant and get it reutilized. So in case of pavement recycling technology, all these pavement recycling technology can be broadly classified into 4 categories. So first is hot in plant recycling, then hot in place recycling, then cold in place recycling, and cold in plant recycling. So all your FDR technology is just about the cold in place recycling. The majority of FDR technology is about cold in place recycling. But the major challenge in this kind of technology, whether it is cold in, particularly in cold in place, all of them are stabilization mechanism. It never gives you a perfectly bounded layer. So it's a sort of an stabilization of an existing material, and the heterogeneity of the material is another major concern, since you never know what kind of material is coming out from the underneath layer, since in that same time the entire extraction process, mixing and laying is carried out. So there is no control on the material quality. Whatever the material is coming out, it is going inside the pavement. But in case of hot in plant recycling technology, since you extract the RAP from the bituminous layer and then segregate it into 2 categories, then we have very good control on the mix properties. So with the help of that, you can really construct a good quality pavement surfacing at an economical cost. So like this one, and so here like this, up to this hot in plant recycling process, the maximum RAP utilization is to 25 to 30%, but with the advent of this RejuPave technology, we have successfully utilized up to 70%. So these are the typical hot mix recycling, hot in plant recycling plant, where we can add the RAP into multiple ways. So depending upon the mechanism of RAP addition, we can quantify the RAP utilization into existing hot mix plant, and the existing hot mix plant can be refurbished for the higher RAP utilization also, so at a very economical cost. So one is the cold feed, through the cold feeding of RAP into the pug mill, then cold feeding of RAP into the pug mill along with the hot mix territory. With the drum also you can put the hot RAP and the cold RAP like that. So by using these combination, we can maximize the RAP utilization. Now where we can put this RejuPave rejuvenator? So it can be added into the virgin bitumen tank of the requisite doses. The doses is around 0.5 to 1% by weight of virgin binder, so that too is quite economical in nature. Or it can be directly sprinkled on the oxidized RAP inside the pug mill. So these are the 2 ways. With using that, we can put the RAP rejuvenator inside it. So it's a glimpse of a hot mix plant where we can do all these stuff. So this is a typical cycle, like a distressed pavement, then milling of distressed pavement surface, then hot mix recycling using hot in plant recycling technique, and then laying of recycled road surface. Now in terms of the cost saving, like if we will go with the different RAP percent utilization right from the 10% to 60%, then the net saving on the per ton production of bituminous mix will be 40.8.1%. 40.81% reduction into the cost of production of bituminous mix, since that much quantity of aggregate and bitumen you are saving. So it's altogether a very cost-effective, economical and eco-friendly process, since you are reducing the energy consumption as well as reducing the greenhouse gas emission using it, since we are not putting any kind of virgin material, whether it is aggregate and bitumen for the construction. So this is the glimpse of the different roads we have constructed so far using this technology. Like first project is on Varanasi ring road project with GR Infra. So here we utilize this Marini hot mix recycling plant, and we utilize the RAP in the tune of 50, 60 and 70%. So this is the glimpse of the Marini plant. And so Rejupe rejuvenator was directly added into the bitumen tank. Subsequently, we laid the surface, and the laying temperature was around 105 to 110 degrees centigrade. This particular site was around two and a half hour far from the hot mix plant location. So by the time the mix reached up to the site, the temperature was around 120 to 125 degrees centigrade, and we completed the laying around 105 degrees centigrade. And at such lower temperature, there is no reduction into the density as well as the mix property. So it's a kind of a very big accomplishment on the project site. These are the test results we have recovered, which we duly signed by the GR Infra road projects as well as the NHI personals. Now the second project on NS34 with Cube. So on this particular location, we once again utilize the RAP in the tune of 50% by weight of overall mix, and we constructed around 1.5 kilometer 6-lane section there using this particular rejuvenator, and that utilization is particularly in binder course layer, dense bituminous macadam layer with polymer modified bitumen. So virgin binder was polymer modified bitumen, but the RAP was containing the VG40 grade bitumen, and we utilized it and constructed it. And now henceforth we are utilizing for the construction of NH53 as well as 2 projects in Delhi PWD where we are using this particular product for the construction of it. So in the similar fashion in the state of Jharkhand also for the rehabilitation of distressed bituminous road network, going on for this fresh bituminous overlay, you can adopt hot end plant recycling technology, which can not only save the natural aggregate and virgin bitumen as well as preserve our ecosystem also, since it will reduce our reliance on natural aggregate, which in turn reduce the quarrying and mining of natural aggregate, which is causing serious environmental impact across the nation. So that's all about for the Rejupe one. The next one is the Terra surfacing technology. So I will just give you a brief about it. So it's a sort of a preventive maintenance technology of 8 to 10 mm thick. So one of the important aspect of this technology is that, like in this one, we entirely use the industrial waste material. It is based on fly ash, steel slag or the marble dust. So in the Terra surfacing, we can utilize 100% steel slag fine as a substitute of natural aggregate for preventive maintenance of the road. The thickness of this treatment is around 8 to 10 mm. It is completely an ambient atmospheric temperature based technology which does not involve any heating of bitumen and aggregate. So all of you might have heard about the micro surfacing technique where the 8 to 10 mm thick layer can be laid on the road surface as a periodic renewal or for the preventive maintenance. In place of that, in Terra surfacing, it is specifically based on the industrial waste steel slag. So with the help of it, like you can lay this special treatment with the help of micro surfacing machine on distressed bituminous road, and with the help of it that we can prolong the service life of the existing bituminous surface. So we carried out the successful implementation of this technology in 4 locations in India. Recently we accomplished this work in Surat, Hazira, where we utilized the processed steel slag aggregate fines of ArcelorMittal Nippon Steel for the construction of this road. So one of the important aspect of this road, like it's a quick rehabilitation method, it's a in situ preparation and in situ laying mechanism. You can open the road for traffic movement within 2 hours itself, since there is no heating of aggregate and bitumen involved into it. Besides that, the cost of maintenance is also very less. The entire cost of the treatment will vary between 120 to 140 rupees per square meter, which is substantially economical in comparison to the conventional treatment. Another important aspect is that, like in case of your cement concrete pavement is showing early sign of distress, then in such cases this Terra surfacing layer can be put on top of it, and it will reduce the quantum of cracking in the surface. So it's a kind of a glimpse of a preventive maintenance benefit using Terra surfacing technology. This is once again, it is on India, Government of India platform Agni, the product. This is the glimpse of the steel slag fine, which we have utilized for the terra surfacing application in the state of Gujarat. So it's a completely 9.5 mm down aggregate, 100% passing from 9.5 mm aggregate. So you can do it in the state of Jharkhand using Bokaro steel plant, the steel slag of Bokaro steel plant, as well as the Tata steel plant. So it's once again a technology which promotes the circular economy, since it reduces the generation of waste material. Besides, we are utilizing the waste for the road construction, so it's a kind of a waste to wealth scenario. So these are the mixed design parameters which has been developed by the CSIR Central Road Research Institute, and this is the application parameter. With the help of it, we can go ahead. These are the different tests which is required to be done in order to carry out the mixed design, which comprises mixing test, cohesion test, test for asphalt requirement and all. So it's a kind of a typical technical mixed design methodology which we need to follow in order to do that. So this is the mixed design parameter which has to be achieved while carrying out the terra surfacing with 3 different types of industrial material, whether it is fly ash, marble dust or steel slag. So in case if you have any of these material available nearby, you can adopt this technology in place of natural aggregate, and we can construct the road using it. This is the glimpse of road work which we have recently completed at Surat, Gujarat using terra surfacing. So in this particular project, we utilize the steel slag fines of ArcelorMittal Nippon Steel, and this is Surat Hajira Port Road, where we use this material for the construction of terra surfacing layer on 2.5 kilometer long road. It's a 6-lane road. So the entire road is treated using it with the substantial less cost. So this terra surfacing and Rejuve technology we have developed along with Burma Industries, and both are the green technology in order to construct a green infrastructure and can be very much beneficial for the government of Jharkhand. That's all from my side. Thank you very much. Thank you.